Today we're going to be solving absolute value inequalities. This kind of combines what we know about absolute value and what we know about inequalities. And there's a couple different ways that you can remember how to set this up. And really, these problems are super easy once you have them set up correctly. So the hardest thing is getting them set up correctly. So first, let's talk about what happens when the absolute value is less than something, like we have right here. The absolute value of ax plus b is less than c. Remember, absolute value represents the distance that something is from 0. So if I use this example, the absolute value of x is less than 3. I want all of the x values that are less than 3 units away from 0. So if we think about a number line, where on this number line would we be exactly 3 units away from 0? At -3 and at +3. If we want to be less than 3 units from 0, we would want to be any of these numbers, like 2, 1, 0, -1, -2, any of the decimals in that range. This means that when we have absolute value is less than, it's an and compound inequality. It is -3 is less than x is less than 3. So when you see absolute value is less than, you're going to set up an and inequality, a 3-part and inequality. And one thing that you could do is think of it as less and than. And that might just remind your brain, if it's less than, I set it up as an and inequality. And you do the negative number less than the stuff in the absolute value bars less than the positive number. So this is a guide for how you set these problems up. Okay, let's dive in and see if we can do this. The absolute value of 2x plus 7 is less than 11. That means we want to set this up. The absolute value needs to be less than 11 units from 0. That means -11 is less than the stuff, 2x plus 7, is less than 11. If it's less than, you set it up as a 3-part inequality. Negative, less than stuff, less than positive. And then we would solve. Do you remember how to solve this kind of inequality from, what was that, Wednesday? What would we do? Subtract 7. So -18 is less than 2x is less than 4. Then we would divide by 2. -9 is less than x is less than 2. Open circles at -9 and 2. And because x is between -9 and 2, you shade in between -9 and 2. Once you get the problem set up, I feel like solving these really aren't all that difficult. It's not going to be crazy, weird inequalities that you have to solve. It's pretty straightforward. Here's an and inequality. Solve it by doing the same thing to all 3 parts. So, is there somebody brave who wants to try to set up number 9 for us? Anyone? Anyone? Okay, go for it. Can I get a second on that? Does anyone else agree? Okay, perfect. -21 less than or equal to 4x minus 9 less than or equal to 21. Notice in this example it's less than or equal to, so that's the symbol that we used. You want the symbol to match what you were originally given. Take a moment, solve this inequality, and graph it. So ultimately you need to remember, if its absolute value is less than, that means the distance from 0 is less than something. So it's shaded in between the 2 numbers. It's a 3-part and inequality. If it's greater than, and a teacher told me to think of it as great or, we're going to set up or inequalities. So if our absolute value of x is going to be greater than 3, our distance from 0 needs to be larger than 3. So we're talking numbers like 4, 5, 6, negative 4, negative 5, negative 6. That would be the kind of inequality where the two shaded ends point in opposite directions. These are or inequalities. X is going to be less than negative 3, farther away from 0 than negative 3, and x is going to be greater than positive 3, farther away from 0 than positive 3. This can be a little confusing to remember, so one thing that I want you to see, one of the inequalities is exactly the same as what we started with, just without the absolute value bars. The other inequality, what changed? Instead of a greater than, it's a less than, and instead of 3, it's negative 3. So the other inequality, both the symbol and the number change, if you just remember that. And I don't care which order you write these, so if you want to write the one that's exactly the same as what you're given first, and then write the one that changes, that's what I usually do, honestly. So I would usually write this one first, and then I'd write the other one. So one of them, ax plus b is greater than c, exactly as you were given, just without the absolute value bars. The other one, you change it to less than, and you take the opposite of the number. So number 10, to set this one up, one of the inequalities is going to be exactly the same. So 3x minus 2 is greater than or equal to 8. The other inequality, 3x minus 2 doesn't change, but we're going to change the symbol to less than or equal to, and we're going to take the opposite of 8. We need to solve both of them because or does not mean pick one. Or means we have to solve both of them. So solve both of them and then graph your solutions. Oops. Especially if you wrote it the way I did, with the one that's exactly the same first, your inequalities might be in the wrong order on your paper, which is fine as long as you just think about, I know negative 2 is on the left, and positive 3.33, or 10/3, is going to be on the right. Less than or equal to, that means we are going to do a closed circle at negative 2, shade it to the left. X is greater than or equal to 10/3, shaded in circle, shaded to the right. Okay, do you see how this is a merging of the last 2 days of stuff? Solving inequalities, that's what we're doing. Absolute value, that helps us to set up the first part. Okay, number 11. First step is to set up the two inequalities so that we can solve them. One of the inequalities is exactly as it's written without the absolute value bars. Negative 3x plus 10 is greater than 5. Who's brave and wants to do the other one? Go for it. Perfect. Negative 3x plus 10 is less than negative 5. You change the inequality symbol and you take the opposite of the number. Take a moment, solve both of them. Do you see how there's a negative in front of that 3x? So when we have to divide by negative 3, what's going to happen? Yeah, we're going to have to flip those signs. Keep that in mind. Okay, some things to remember as you're solving these two inequalities. When you divide by negative 3, it switches that sign. Same thing with the purple. When you divide by the negative 3, it switches that sign. So keep that in mind. Especially when you're trying to graph on a number line, leaving it as 5/3 is certainly easy, but if you don't know what decimal 5/3 is, you're not going to know where to put it on the number line. So it's worth it to at least figure out what that decimal is. So 5/3 is definitely on the left, 5 is on the right. X is less than 5/3, open circle, shaded left. X is greater than 5, open circle, shaded to the right. How do you all feel about this? Okay.